How are you all students? Welcome you in my YouTube channel Kavi Vinay Badhani. I am Vinay Badhani, your physics online teacher. Last day I taught you about that charge, surface and volume distribution, and now today I am going to explain you the electric field, electric force lines and the electric field intensity. Now let's get started today's topic. Now today's topic is the electric field. Before knowing the property of the electric field, we have just discussed about the Q and Q0 charges. Q is called source charge and Q0 is called test charge. Source charge produces the electric field and test charge is only determine the presence of the electric field. The test charge is very smaller in comparison of source charge and it has no electric field. It has no electric field, it's just a test to the presence of the electric field. It also known as fictitious charge. Fictitious charge. As we know that like charges repel each other and unlike charges attracted each other. So if we have this plus Q charge, source charge situated at a point O, and the another test charge is situated at a point P, this is Q0, which is separated at a distance R. As we know that these have similar charges, positive charge, they repel each other because similar charges repel each other and opposite charges attract each other. So we can easily explain that the electric field, about the electric field, a field in which a charge experiences a force of attraction or repulsion. It is called the electric field. A field in which a source charge experiences a force of attraction or repulsion due to the other charge or due to the test charge. This test charge is called the electric field. The electric field is extend up to infinity. Now on the basis of the electric field, we just define electric field lines or electric force line. Those lines, here lines, electric force lines and electric field lines. Those lines which just gives us knowledge about the electric field direction. Those lines which gives us the knowledge about the electric field direction, either it will in this direction or either it will in this direction. The electric field, the arrow indicate the direction of electric field from here to there, from there to here. In positive charge case, in positive charge bodies, the electric field direction will be outward, and for negative charge bodies the electric field direction inward. Note down this point because it is very important for your examination and for next topic. If we draw electric field lines or electric force lines from the surface, from the sphere, if we draw electric field lines from this sphere due to positive charge, then the electric field direction or lines will be outward, because I explained in the previous condition this. The electric field direction outward. And if we have a negative charge sphere, we just draw the electric field lines, then the electric field lines due to this negative sphere will be inward. And now the electric field lines due to positive charge and due to negative charge is this. Here it will be move outward direction, here it will be move inward direction, and the direction of the electric field lines from positive to negative, from positive to negative, from positive to negative. Note down this point. If we have two positive charges, then the electric field lines due to these positive charges will be outward, as we know that. If the other positive charge will be come in contact with each other with these charges, then they repel each other, and the neutral point is situated at the middle of these two charges. The condition is this. If we have similar and equal charges, similar and unequal charges, for then the condition is this. This is positive, this is positive. They repel each other, they repel each other. This is Q1 charges plus Q1 charges for similar and unequal charges. Similar charges but unequal, not equal. The neutral point is not situated at the middle of these two charges. If R1 is the distance of this Q1 charges from the neutral point and R2 is the distance from the neutral point of Q2 charges, then we have easily find that the relation between the first positive charge and the second positive charge is here. Q1 upon R1 square is equals to Q2 upon R2 square. On the basis of this formula, we easily find that the numerical problems which is upcoming. Now we discuss about that electric field intensity. As we know that if you have two charges, plus Q and plus Q0 charges, one is source charge, other is test charge, which test the presence of the electric field and which produces the electric field. Then the electric field intensity is defined as the strength of the electric field, or can say the strength of electric field is called electric field intensity. It is denoted by E, or can say force per unit test charge is called the electric field intensity, or the strength of the electric field is called electric field intensity. In the vector form, we can easily write this. Its unit is Newton per Coulomb and its dimensional formula is, as we know, that force upon force per unit charge. Force dimensional formula mlt की power minus 2 and q equals to it ml t की power minus 2 q I a t, and here is ml t की power minus 3 a की power minus 1. This is the dimensional formula of the electric field intensity, and this is the electric field intensity unit, Newton per Coulomb. Now we discuss about force on a charged particle due to an electric field. Suppose that we have a charge Q, charge body is Q, which is placed in an electric field. Then the force work done on these charged particles is equal to as we know that the definition of the electric field intensity E equals to F upon Q0, but we just discuss about force on a charged particle. This is charged particles which is placed in an electric field. Then the force is equal to F equals to Q0E, which Q0E or F equals to QE. Q is the charged particle, E is the electric field intensity, F is force work done on this charged particle. If a charged particle is placed in an electric field, then the force work done on this charged particle is equal to product of the charged particle and the electric field intensity, F equals to QE. On the basis of this formula, we can easily find the electrostatic force work done on a charged particle when it is placed on in an electric field, and also the electric field intensity equals to F upon Q0. The value, if we have the value of F and Q0 is known, that we can easily find that the electric field intensity, and we can easily find the electrostatic force work done on a charged particle. Now the next topic is intensity due to a point charge. How we can calculate the electric field intensity due to a point charge? Suppose that this is O point. A point charge is Q situated is here, and at R distance from O, a point P is situated in which a positive test charge particles situated. We can easily find at that point the electric field intensity due to a point charge. The force work done direction will be here, and this distance is R, and this is O, which is the electric charge is situated, and at a point P the test charge is situated at a point P. Then how we can find the electric field intensity? As we know that according to Coulomb's law, F equals to 1 upon 4 pi epsilon naught K q0 upon r square Newton. And intensity, we can find electric field intensity due to a point charge from the definition of the electric field intensity, E equals to F upon q0. This is equation number 1. This is equation number 2. Value of E, value of F from first putting into second, or can say putting the value of F from first into second, then what will become? F value is this q0 upon r square and upon q0 cancel, and 1 upon 4 pi epsilon naught K q upon r square Newton. And here we can easily find that 1 upon 4 pi epsilon naught K q upon r square Newton per coulomb. But the condition is this: for vacuum and air, K value is 1 for vacuum and air. Then we have 1 upon 4 pi epsilon naught q upon r square Newton per coulomb. This is the formula of the electric field intensity due to a point charge. Suppose that as we know that for positive test charge particles the electric field direction will be outward, and for negative charge the electric field direction will be inward. So if you have a multiple number of charges in a system, q1, q2, q3, qn, multiple number of charges situated in a system, then the electric field intensity for each particle, for each bodies, for each charge bodies have different and the distance of the each and every charge bodies will be different. Then the electric field intensity for q1 charge particle is equals to q1 upon r1 square, and for E2 q2 upon r2 square, and for E3 1 upon 4 pi epsilon naught q3 upon r3 square, and for n particles, n number of particles, 1 upon 4 pi epsilon naught qn upon rn square. And the resultant electric field intensity is equal to the algebraic sum of the multiple number of electric field intensity due to different types of, or due to multiple number of charges in a system. Then we can easily find that E1 plus E2 plus E3 after 2 n terms. Okay, are you getting it? The next topic is intensity of electric field due to uniformly charged ring. Intensity of electric field due to uniformly charged ring. It is clear that on the topic heading uniformly charged ring, suppose that we have a ring. This is a ring, and which is uniformly charged. And its center point is O. And this point, the radius of this ring is A, and the point here we just denote it AB. This is a small area of the ring. and at x distance from O, a point P is situated, which we have to find the electric field intensity. From x distance, a point P, and the distance from AB to P, the distance from this small area to the point P is R, and this P point, which we can find the electric field intensity, makes at an angle theta from AB. If this makes an angle theta, then it will be divided into two components, which is vertical components and the horizontal components. If we just increase this line in outward and this, then this angle equal, this is delta E, this is delta E. Horizontal component is cos theta and vertical component is sin theta. The vertical component of this ring is same here and here, but opposite in direction, then they cancel out each other, and the horizontal component is delta E cos theta. They are add each other because they will add each other because they are in same direction. And then from this figure, at a point P, the electric field intensity due to this small area, the charge is also Q, small. Electric field intensity at P due to a small element, then the electric field intensity will be also small, 1 upon 4 pi epsilon naught delta Q upon R square. In the direction of horizontal component, in the direction of the electric field intensity, the horizontal component is this, and from the figure we can easily find the cos theta value. Cos theta value is base upon diagonal x upon r, and we know that the theorem of Pythagoras is the diagonal square equals to base square plus normal square, and the value is this, and R value is a square plus x square to the power 1 by 2. Now the final formula is this. Because of this is 1 upon 4 pi epsilon naught delta Q upon R square value is here, a square plus x square whole 1 by 2, and a square plus x square, R square is R square plus x square, and x upon R is 1 by 2 and 3 by 2. And special condition arises in this, special condition. Suppose that this point P is situated at the center of this ring. If this point P is situated is the center of this ring. Then x equals to 0 and e equals to 0. In second condition, if this P point is far away from the center point of the ring, then what will happen? X is greater than a. This x is very, very greater than a. And we can take a square is very negligibly in the comparison of x square. A square equals to 0. Then we can find this formula, E equals to 1 upon 4 pi epsilon 0 q upon x square. It means the electric field intensity behave like as a point charge in the condition of electric field intensity due to uniformly charged ring. Now the maximum condition for the maximum condition of the electric field intensity at the axis of ring. As we know that it is clear from the heading, for maximum condition the electric field intensity at the axis of ring. In the case of the maximum and the minima, for maximum condition d upon dx equals to 0, d upon dx equals to dy by dx, E value is q upon 4 pi epsilon naught x upon a square plus x square की power 3 by 2, and we can write this dy by dx x a square plus x square की power minus 3 by 2 equals to 0. This is clear? Are you getting it? D upon dx q upon 4 pi epsilon naught, and this is first function, this is second function. Now differentiation of this whole function, whole part in the form of first function and second function. A square plus x square minus 3 by 2, first function differentiation is 1, plus first function differentiation of second function minus 5 by 2 and into 2x equals to 0. And now a square plus x square minus 5 by 2 a square plus x square minus 3x square equals to 0, a square plus x square minus 3x square equals to 0, d upon dx, d upon dx. Here a square minus 2x square equals to 0, 2x square equals to a square, x equals to x square equals to a square upon 2, and x equals to plus minus a by root 2. The condition is this: the electric field intensity will be maximum at the distance x equals to plus minus a upon under root 2. Now enough for today's, and in next topic we will discuss about that the electric dipole and electric field intensity and much more. Thank you.